So this is going to be a little different for example 10. I'm going to introduce this to the next one itself. Okay. So example 10 says order 2,500 milliliters D5W IV for 6 hours. The drop factor is 10. So they give us a drop factor. A says, find the flow rate in GTT per minute. Well, same thing, right? Infusion. Okay, not too bad. So 2,500 milliliters. Oh, sorry, for 6 hours, right? And we just convert that to GTT per minute. So, for every 1 milliliter, there's 10 GTT. And then for every 1 hour, there are 60 minutes. So canceling and multiplying should give you 69.44 drops per minute as your answer. Okay. Now let's look at B though. After 4 hours of infusion, 600 milliliters remain to be infused. Calculate the new flow rate in order for the infusion to finish on time. Okay. So the flow rate is now going to be changed. Now we want the new one. Now, after 4 hours, 600 milliliters remain. So now what is our flow rate? 600 milliliters for what? So it's not for over 4 hours, right? It's actually over 2. Because how much time does it still remain? Well, what's 6 minus 4? 2 hours, right? So there's still 2 hours remaining. So that is our flow rate here. And now we do the exact same thing process we did up there. So I just converted the GTT per minute. We'll just say roughly that. Roughly 50 GTT per minute. Okay. Now again, right, if you're wondering why it's 2, it's, well, after 4 hours, meaning 4 hours already elapsed. How much time is left over from the 6 hours? Hopefully that makes sense, right? It's 2 hours left over. So you still need to infuse 600 milliliters in just 2 hours, not 4 hours, right? Now, this is an interesting concept we're going to talk about asking right now. So when this happens, so this is called adjusting the flow rate. So many hospitals have a policy on how much you can adjust the flow rate of a patient. In most cases, the question will give you the policy in percentage the flow rate cannot exceed. Okay, and in order to find this, we'll use the rate of change equation, so the fraction of the change. So the fraction of the change is the change of rates of the difference between the flow rates. It's always largest minus smallest. So the difference between the flow rates divided by the original we started with, and I forgot, times 100%. This is a percentage. So times 100. Okay. Right? So that is our portion. So the difference between them, largest minus smallest, so you always get a positive, divide the original, so the one we started with, and just times it by 100. That gives you the percent. Okay. So to give you that portion, let's suppose we have the same scenarios above. So given the last example flow rates, if the policy of the hospital is the flow rate adjustment cannot exceed 30%, is the flow rate adjustment in the policy guidelines? All right, so let's find out. So first thing we have to do is subtract the differences. So largest minus smallest, so 69.44 minus 50 divided by the original. So what do we start with? So we started with this one, right? That was the adjusted one. So we started with 69.44. So order operations, right? First subtract, then divide, then times it by 100. And once we do this, we should get approximately 28%. So is it in the guidelines? Yes, right? So it's less than 30%, so it's a yes. Okay. So that's going to be the concept here. So this, when it comes to these type of questions, they will always tell you what the guideline will be in the question. So they're not going to, blind you up and see what's actually going to happen there. Okay. Right. So let's go to the very last concept of this chapter is of balance when it comes to it. It's very simple, but it's just quick little example illustrating this. Okay, so this is a fluid balance and replacement fluids. Okay, so there's, one of the major fluids are replacement fluids. This is a process where you will replace the fluids that leaving the body with fluids to aid the patient. Okay, so basically fluid intake, right? You need an IV, respectively, in fluid output. Urinating, sweat, all that fun stuff. So it's the amount of fluid going in, so IVs, orals, etc., and outputs is leaving the body respectively, right? When it comes to it. So in most cases, we're going to figure out here. Obviously, you want more input than output, right? Because you don't want the patient, to dehydrate that kind of portion. So the easiest way to deal with it is always label as best you can. Okay? So let's just try this example so you can see what I mean by labeling. So order says for every 150 milliliters of urine output, replace with 60 milliliters of water per 3 hours. Okay. So if a patient has a urine output of 365 milliliters, what is the replacement volume? Okay, so it's the same exact process. We're always using what we're given. So what we're given is this patient had 356 milliliters of output. Okay. Now our equivalency is for every 150 output, we replace with 60. So remember, we want to cancel our output, so we know for every 150 milliliters out, there are 60 milliliters of input. So notice these cancel so you know what actually multiply when it comes to it. So therefore, once we multiply and divide, we should get a total of 142.4 milliliters of water. So that's what you're actually inputting, right, when it comes to it. Okay. So it's the same concept as, when it comes to it. Just be careful when it comes to input, output, how you actually label it, because, labeling is a key part when it comes to it, to figure out what actually goes on top and what actually goes on bottom, based on the equivalency given to you in the question.